Okay, today what we're going to do, guys, we're taking what we've already learned on the ratios, and really what we're doing is giving you a format to put them in. The format for today is called a ratio table. And we kind of did that last lesson. You guys saw how to put them together. But now we're actually going to take those tables that we've made and start doing comparisons. So we can compare data and understand bigger or less what the data is actually telling us. When we compare ratio tables, I've developed these 3 steps for you. This is kind of how Mr. Moore would do it, because I tend to be lazy and want the easy way. So I'm going easiest to hardest. The easiest way, if you're going to compare ratio tables, is look at the 2 tables and in the same line. That's really important. I can't compare a top line to a bottom line or side to side. I have to have a common entry for all the tables that I'm comparing. So if I've got the same entry in one of those lines, I can then look at the number associated with it and make my comparison. And we'll see that as we do some of the examples today. Number 2, look for an easy extension. If I can see a pattern in the tables and say I don't have a common one I can do right now, but if I extended this table 1 or 2 more entries, I'd get one, go ahead and do it, because it's actually the easier way to do it. But don't just continue extending forever. There's some tables you may not ever find a common entry. So again, it's only if you're looking at it, your math spidey senses are tingling. You say, hey, I've got 1 more entry, I can get something, do it. Otherwise, go to step 3. Step 3 is use the values of the first entry from each table and cross multiply to compare. Any guesses why I say use the first entry and not the last entry? Arthur? You're on the right track. Okay. And that's actually another way to do it. I can simplify on my first entry. And if they're in simplest form, sometimes they'll match up. But the other thing is, which is easier to do the math for if I'm multiplying the smallest number or the biggest number? Smallest. So that's really why I say use the first entry, guys. It's going to make math easier for you. So let's take a look at an example to try to help you understand all this. So the first example we're going to use is we've got a 120-pound person who would weigh 20 pounds on Earth's moon. A 150-pound person would weigh 28 pounds on Io, which is one of the moons of Jupiter. Use ratio tables to determine which moon would make a person weigh the most. So right here is our task, other than using the tables. So we can actually circle both of those. So we got 2 tasks here. We got to make the tables, and then we're going to use those tables to figure out which one makes the person weigh the most. So let's figure out what we're looking at. First off, we've got the Earth weight versus the moon weight, right? So those are the 2 things we're going to compare. So anytime I start putting out things like this, I'm going to identify my variables. So E is the Earth, M is the Earth's moon, so we'll just put moon. So on Earth, so we're looking at the Earth moon for our weight. What is my first entry going to be? What do you think, Xavier? What's the Earth weight for the first person? 120. 120. What's the moon weight for that same person? You know you have it right in front of you as well, right? You don't have to look at the board. You should have anyway, if you wrote it down already. Allie? 20 pounds, right? Does everybody see that? Okay. So now I need to do my next entry. We'll go ahead and build this table before we go to the second one. So what am I going to do to get my second entry? What do you think, Shannon? I started at 120. How am I going to find my second entry? No? Jocelyn? Adding what? Are you doing the top or the bottom? Or both? So I add 20 to both? Does everybody agree with that?
No.
Who said no? Why not, Isaac?
Because there's no 40.
There will be if I add 20 to the first 20. Paul?
It's not a 1-to-1 ratio.
Because it's not a 1-to-1 ratio, is it? If it was 20 to 20, I'd add 20 to both sides. But they're not both 20 to start with, are they? Let me just point out, guys, one thing that's different on this. So far, we've been giving you tables like this, and you build down. This is the same concept, but I'm just building to the side instead of coming down. Right? So I will give you, you do add 20 to the bottom. So that now that second entry is 40. But what am I going to add to the top? Sarah?
40?
Why?
20?
Why am I adding 20 to the top?
Because you added 20 to the bottom.
No. Kennedy?
Because you would add like 100 to like the bottom number. Like,
Say that again.
you would add like 100 to the bottom number.
Why?
I guess because it's like 20 and then it says 120. I guess.
Okay. But remember, when I build my table, I have to do the same thing going over, right? So we chose to add. So do I always add the same value on top and bottom? Or side to side? Jocelyn?
You should add another 120.
Why?
Because it's 20 pounds on the Earth's moon. So you should add another 120 to get.
Good, because now I'm on this column, so I'm adding 120 on the top, right? So that's going to make that 240. Is there anyone unclear on why we're doing this? Literally, all I'm doing is taking the values from my initial entry, and I just keep adding that value to build my table. Make sense? So what am I going to do next on the top? Paul? Add 120. What am I going to do next on the bottom? Add 20. Everybody good with this? Okay, so again, for showing your work, that's showing your work. So I can now see, you understand my pattern. I'm adding 120 every time on the top, adding 20 every time on the bottom. So once you've shown your work on the first two, now I'm okay with you just going ahead and continuing that pattern. So it's going to give me 400, 480, 600, 720, 840 on the top. On the bottom, it's going to go 60, 80, 100, 120, 140. Is there anybody unclear about where any of those numbers came from? Okay? So, which way did we do this table? Who remembers what kind of table that is? Arthur? Additive. Awesome. Good job. So, since we did additive on the top, I want to actually use our other method on the bottom. Who remembers our other method? Multiplicative. Awesome, Olivia. Okay, so what is my first entry for my second one? In other words, what was my second ratio, Isaac? Good. For the Earth weight. And then what was the moon weight? Good, Isaac. 28. Okay. Now we also need to label this. This is the other moon. So I'm going to add up here the I is Io. So we're keeping track again of what all these different letters mean. So as I look back at it later, I can still understand what this whole problem was, right? So now we're going to do a multiplicative. So how do I do that? What am I going to put for my work for that second one? My second entry would be times. So it's my second entry, so it's going to be times. Good. So my second entry would be. What am I multiplying by? No. 2. Because it's my second entry, I'm going to multiply both of my initial numbers by 2. So I'm going back to and remember, when we do multiplicative, it's always about coming back to my initial entry. So I'm going to multiply both of those numbers by 2. So that gives me 356. The next entry I'm going to multiply by 3. But what am I multiplying by 3? That initial entry. So remember, when I'm doing multiplicative relationships, I always come back to that initial one. So we've got 450 and 84. Then I'm going to do times 4. Gets me 600. and 112. Then I'm going to do times 5. That'll get me 750 and 140. Then I'm going to go times 6. That will get me 900 and 168. Then I'm going to do times 7. Gets me 1,050 and 8096. Am I done? Why not, Olivia? Which was? What was the question? Good. So, here's where we get to the steps up above, guys. The way we go about solving this is I now look for a common entry. Kennedy, you find one? What'd you find?
600.
600, okay. Good. So she said, okay, I'm looking at the earth weight. Here's an earth weight of 600. Here's an earth weight of 600. So that is what we call a common entry. Same line. It's both on the top lines. And that's really key. I can't do a top line here and a bottom line there. That's not going to work. I got to be comparing the same thing. But once I found that common entry, now I can look at the information that goes with it to make my determination. So which moon would make a person weigh most? That 600 pound person that weighs 100 pounds on the Earth moon, or the 600 pound person that weighs 112 pounds on Io? Which one's most? Allie?
The bottom one.
Io, right? So, again, because it's a word problem, we'll answer in a full question. Io would make a person weigh the most. Questions on that? Okay, I do want to point out something though. No one in here spotted it, or at least mentioned it, but I also could have said, well, here's a common entry, isn't there?
That's what I was gonna say.
Were you?
Yeah.
Well, there were several. I'm sorry, I didn't call on you. Peng, right?
Yeah.
So Peng, here's the issue though. Now I'm looking at the actual moon weight, right? What's the question I'm trying to answer? Which moon makes the person heavier, right? So let's look at our associated data. So this one, the associated weight 750, this one's 840. So which one's heavier? How'd you get that? Isn't 750 smaller than 840?
Yeah, it is.
So then why are you saying Io? Go ahead. Peng?
So earth weight would be 140, right? And that means just multiplied by 4. Well, the top one is multiplied by 6. So we multiplied it by a smaller number. So I will make it heavier.
How does a smaller number make you heavier?
Well, because since you do 150 times 4, which equals 750,
Uh-huh.
and we get 40, right?
Yeah.
Well, that is a source, right? And 120 times it by 6.
But here's the problem I'm having with your analysis. Was I using the same number? 28 and 20, right?
Right.
So there I can see where you're saying I got there quicker, but I'm using a bigger number, so I'm going to get there quicker. But how does that reflect the weight of that person on Io? Because I started with a different number. I like your thought process, and I'll be honest, you're on the right track. You're just missing the crux of it. Anybody help her out? Why is it that I can say the guy who's 750 actually weighs more on Io than the guy that weighs 840? Andrew? No. Yeah.
840 is the most you can multiply on IO, but
But again, am I using the same weights? So just be careful of how you're making your analysis. You guys are doing a great job. You're really thinking hard, and I love it. Israel, you can help us? Right, so why am I picking the guy that weighs less on Earth to say that the moon makes him weigh more? You're so close. I thought you had it, Israel. Go ahead.
One man's heavier than the other man.
Right. He's heavier. So how am I saying that the Io moon makes him heavier when this guy's heavier?
So the man who weighs the item that weighs 840, right? The moon weight 140, right?
Yeah.
So it's heavier than the guy on the item on 750. So it's going to be the person who weighs more on the moon than on Earth is going to weigh more on Io.
You were so close. I thought you had it. And the way you finished, I'm not quite sure you got it yet. Let's go. Paul, give me another shot.
Okay, so on Earth, the person was at 840.
Uh-huh.
The original one multiplied by 6. But on the other one, on Earth, it was multiplied by 4, so it was less.
But again, we have different start weights. So that analysis, you got to be careful, guys. Because I'm starting at a different spot, yeah, I'm going to get there faster because I started with a bigger number, right? So you're so close, it's killing me. I'm about to just give it to you, Israel. Yes. $750 on the Earth. Right. But that same moon weight of 140 on the Earth, that guy weighs 840. So why is it that this moon, the Io moon, is making him weigh more? Olivia?
Because the starting point of the guy on the second problem below it is less than the one on
The Earth moon. You guys catch that? That's really what it is. Okay? If I've got the same moon weight, which moon is actually making that person heavier? The guy who's lighter on Earth is now made heavier because he's on Io. So that's why I'm using the smaller Earth number now to answer which moon makes the person weigh more. The concern for me as a teacher is when you see a person weigh the most, you're going to just look for the biggest number and ignore what those relationships are. You really got to think in depth, guys, about all these problems to make sure you're answering the question properly. Fortunately, you guys saw that 600 first, so it made it very easy for you. I think if we started with that 140, you guys would have had a much harder time answering that question as long as it took in that discussion to get us there. Does that make sense to everybody? Yes? Okay. Awesome. Let's go ahead and open up our modules then to page 42. It is recorded.
Okay. I want to see who's ready. Page 42. We're going to do a couple of examples, and then you're going to work a little with your group. Okay. All right. Let's see. This table is ready. Awesome job. Right, start table right here. We're ready. Right there. Logan. I think we're good now. Okay. It says create 4 equivalent ratios. There are my instructions. Create 4 equivalent ratios. Equivalent ratios. What does that mean? Olivia. Equal. Ratios that are equal. Good. 2 by scaling up. 2 by scaling down. Using the ratio 30 to 80. Okay, let's talk about the word scaling up and scaling down. What in the world are they talking about there? Jake?
One of them goes down, one of them goes up.
Okay, so one of them will increase, right?
Yeah.
All right, the numbers will increase and one of them, the numbers will decrease. Still equivalent ratios, okay? So what's my original ratio? Come on.
30 to 80.
30 to 80, good. All right, do we want to scale up or scale down first? I don't care. Up, okay. Talk to us, Olivia. What are you going to do? You can. Multiply by 5, by 6, make it go up. Let's do 2. Okay, you said 2 originally. All right, times 2, that gives us what? 30 times 2 is?
60.
80 times 2 is?
60.
Good. All right. There's one of my ratios, okay? What else do we want to do? Talk to us, Arthur. Okay. Oh, good, Arthur. I hadn't heard that one yet. He said we can go ahead and use what we have here, the 60 and to 160. Just multiply that by 10. We're still going up. We're still increasing. Okay, that gives you what? Add those zeros. What does that give you? 600. And then 1,600 or 1,600. Very good. Now, we've scaled up. Let's scale down. What can we do to scale down? Sarah?
Divide by 2.
Yes, let's go back to our original and divide by 2. Which gives you what?
15 and 40.
15 to 40. Good. Anything else?
Wait, I don't know.
Look at 15 to 40. Yes, Christine.
Divide it by 5.
Bingo. All right.
Yeah.
And that gives you what? 3 to 8. There you go. Those are your 4 ratios. Scaled up, 2 scaled up, 2 scaled down. All right.
Wait. Okay.
Okay, let's look at the next part. Write a ratio to describe the relationship shown in the table. And here are my instructions. Write a ratio. Write a ratio. Okay? Guys, I see a lot of ratios there. That's what I asked the last 2 classes. Like, what? There are ratios there. What are they talking about? Oh, wait. Ooh, say it again, Gavin. Simplified, right. Simplified. Okay? Where did all these other ratios come from? They want the simplified version from all these ratios or of all these ratios. Okay? Talk to us, Sarah.
I think that,
Sarah, what might be the best ratio to use? Mr. Moore explained it, I think, in the first example.
10 to 80.
Oh, okay. Well, we could do that. Okay. Yes, Olivia? A 5 to 40, we could do that as well. Yes.
We could use 2 to 16.
Okay, all of these are correct. All of these are correct, and I see actually why you did 10 to 80. In the example he was talking about, he used the first one simply because of what, Christina? Yeah, it's the smaller numbers, but Sarah, I like what you said about the 10 to 80. Real fast, divide by 10, right? Easy. Okay, so I do see why you pointed that out. Olivia, we could do 5 to 40 as well. I mean, you can use any of them, pain. Okay, so let's use 2 to 16. I'm also going to throw up there 10 to 80. I like that. I see where Sarah was going with that. Divide by 10. That gives you 1 to what? 8. And same thing here. Divide by what? 2. Okay, this is the one Christina was talking about. 1 to 8. Okay, so write a ratio to describe the relationship in the table, 1 to 8. Here's just another way to write it. Okay. Yeah, they're all equivalent. Exactly. That's what I was saying. Absolutely. They are all equal. Absolutely. Okay. Very good. Exercise 1. I love this problem. Okay, the following tables show how many words each person can text in a given amount of time. Compare the rates right here. Compare the rates of texting for each person using the ratio table. Okay, so our instructions are to compare the rates. What do we do when we compare? Because right now I just see 3 tables or 3 charts. So what are we doing with this? They're filled out. What are we doing, Gavin? Okay, a common number, but if we're comparing them, what are we looking at? I'll go with the simplifying. I like that. Olivia?
Wait, couldn't we find like we did in the last?
Yes. Okay, hold that thought. Let's back up though. When it says compare the rates, what am I going to write out here? Like ultimately, what are they asking me to do? Olivia?
If you do it.
You could. Okay. You could. I love all your ideas. But ultimately, what are they asking us? Hey. Huh? I just can't hear you.
Divide.
Oh, divide. Okay. All right. Yes. So they're asking us. What I'm looking for is they're asking us to tell them who takes more words per minute, right? Or maybe the least words per minute. We're comparing them. Okay. So ultimately, that's what they want to know. And you're giving me all different ways you could do that, Olivia. Let's start with what you said. What did you say first? We could cross multiply, but you said something about like what we did on the last one. What did we do? Yes, find some numbers they have in common, which I see what? What, Jade?
816.
Okay. I see a 3 right here. The 3. Okay, let's talk about that. So Michaela, every 3 minutes, and you guys know about this. You guys know about it way more than I do. This texting. Michaela's, okay, she's on that phone. She can text 150 words in 3 minutes. Okay? Boom, 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 boom. She's got 150 words out in 3 minutes. Guess what? Maria? 120 words. She's still quick on that phone, but not quite as quick as Michaela. Okay. Now, Jenna, we're at a loss. Now, I see right here, for every 2 minutes, she can text 90 words. And then it's like, oh, wow, she's not fast at all. But she's only got 2 minutes, right?
I mean, like,
that's hard to compare, right? It is. But all of these, or both of these, Michaela and Maria, they have 3 minutes.
Yeah, 3 minutes.
Right. And Jenna, it's only 2. We can't compare that yet. What can we do? We see Michaela and Maria. What can we do, Olivia? Okay. Well, and they did. We're scaling up right here. Okay. I like where she's going with that. What can we do? We need to do what? We need to divide or scale down, right? What are we dividing by, Sarah?
Word.
You got it.
Divided by 2.
Okay, I knew that was what you were thinking. Okay, and why are we going to divide? What are we looking for? What are we looking for, Peng? She's correct. Per minute? Yes, absolutely. So if we know per minute, so we know every 2 minutes it's 90. Sarah said, let's divide it by 2. For every 1 minute, it's how many words? 45. Good. Okay, I'm going to make a little place right here. For every 1 minute, it's 45 words. Okay, does that help me? Yes, it does. I still can't compare that yet, but what can I do with that information? Talk to us, Kayla. No? Come on. Yes.
At 90 or 45.
Okay, why?
So, So if 1 minute,
Yep.
1 minute, they give 45 words. If that's that.
I like that.
45, 90.
Good. Okay, I hadn't heard this in the last two classes. Awesome. He said, look right here. 1 plus 2 is 3 minutes. That's going to give it the same amount of time. And so he said, add 90 and 45.
It's 135.
Okay, could we do that? I also heard in the last class, which was awesome too, Miss B, just multiply 45 times 3, because 45 is 1 minute, 2, 3, right? Okay, same difference. Awesome. Good. I like the way of thinking. Good. Okay, so that gives us what? 135. So for every 3 minutes, I'm just going to put this over here. It's 135. Okay. Now, let's talk about this. So, who can text the most words per minute? Who? Michaela. Okay. Michaela, then who? Jenna, because we've got 135, and then Maria. Okay. So, I'm going to put Michaela can text the most words per minute.
Michaela.
Yes, right?
No, Maria. No.
Maria. So, again, we've got 3 minutes for all of them. Logan, is that Logan?
Yeah.
Okay, so we've got 3 minutes for all of them. Look, 3 here. Michaela does. Yeah, and then Jenna can text 135. I'm sorry. Yeah, Jenna, and then Maria is 120. Okay. All right. Let's go to this next table. Yes, Christine.
I haven't tried.
Oh, hold on. Let's go back. Okay.
If you could just reduce
Nice. Okay, say it one more time, Christina. Okay. Somebody up here still talking. Did y'all hear what she said?
Yes.
Yes. What did she say?
Chris, someone's in a
Ah, okay. It's always how it goes, right? Okay. She said we could reduce all of them to words per 1 minute, right? Yeah, and figure it out from there. Absolutely. Great strategy.
Miss B, before you go back, just real quick, because Olivia actually started it with the very first one. She said, I could have actually just taken that second one and extended one entry. So if you'd have done that, you'd have had 10 and 450. That would have given you a common comparison between Michaela and Jenna as well. And then you could have done that double comparison.
Nice.
Where they all rank.
Nice. Okay, we're up here.
The second one, yeah.
Second.
So she's going up by 90 on the bottom.
Oh,
But she
gotcha.
saw that if I did one more entry, she's at 450. Well, Michaela's last entry is 450. You just say that it takes
Right.
10 minutes to get 450,
Right.
where it's only 9 for
Good,
Michaela.
Olivia. Good.
Michaela's
Nice.
Yes, sir.
This reminds me of third grade when I don't understand anything, but I do now. And now, if I look back, I would use
Okay. Did everyone understand what Olivia said? So you're saying add 45 here, right? And then make minute 3, so that she could just compare the 3 minutes. Okay? Nice. Good, Olivia. I love this. So many different ways to look at it. So many different ways. Okay, let's look at this one. Complete the table. Right here are my instructions, so that it shows Max has a texting rate of 55 words per minute. Okay? All right, where are we going to start? Olivia? Yep. Very good. Yes, per 1 minute. Okay? Per 1 minute. So, from here, what are we going to do? Gavin, talk to us.
We're going to do a second additive.
Okay, you want to do an additive? Okay, what are we going to add across the top? Add 1. Okay. Okay, and across the bottom,
55.
which is,
21.
okay, and 55 more is,
25. That's 28. I made it 160.
okay. Are we good? I'm sorry, what did I?
Showing you how to.
Oh, yes, thank you, I'm sorry, yeah. No, this is yeah, I need to make that clear. 55, it's hard with this. Plus 55, thank you for reminding me of that. Yes, Logan. Just sign out, remember, you don't have to ask. Okay, any questions on this? All right. Let's look at exercise 2. This is on page 43.
Yeah.
Okay? 43
Yes.
and 44 continues. 43 to 44. I'll wait till you're done here. Because you got a lot going on with your comments and your huffing and puffing. Okay. 43, the rest of 43 and 44 is what you are working on now. You have about 11 minutes. Okay? Yes, question. You can, good question. You can phone a friend at your table, not across the room. Okay, so you can talk amongst your groups, absolutely. All right, but you just can't yell across the room. Okay? Any other questions? All right.
Okay, really key on these, that you are marking your text to understand what we're doing. Tables below show a comparison of the amount of water to the amount of juice, concentrate, in grape juice made by 3 different people. Whose juice has the greatest water to juice concentrate ratio? Whose juice would taste strongest? So there's kind of the thing. When I look at tasting strongest, am I going to have more water or less water? Well, how does that make it stronger? Because there's more juice there, right? So what I'm saying is, who has the least amount of water to see who's got the strongest drink, right? So let's look at it. Again, the easy way to do it, common comparison. Where do I see a number that's the same between at least 2 of the tables? Olivia? 15. Okay, 15 for Laredo, 15 for Franca. So, if he's got 5 things of juice, she's only got 3. Which one's stronger? 5. So between those 2, we can say he's 1, he's 2, right?
Yes.
Everybody go with that?
Yes.
Okay. So we need to make another comparison. Where's another one that you see? Yeah? 40? Okay. Okay, so Franca, 40, Milton, 40. Who's stronger? Milton, because he's got 10 to her 8, right? So, Franca lost to both of them, so where is she going to be? Last. But do we know about Milton or Laredo yet?
No.
So do we have a comparison they can make, Jocelyn? How'd you do it?
So I found that the concentrate for Franca are those 2 in the first country, but one of
So you just used a different one. So she said it's here and here.
But I did it like a different way. Because I used was emphasize more water.
Okay.
That thought is more watered down.
Yep.
So you can, so Franca had more water.
Yeah.
And
Meaning she was weaker, so she lost.
and then I knew that to get to double, so 4 is the first answer for Leonardo's concentration, but to get to double of that, to double of Milton's, would you have to be 16.
Okay, so she did that second option I gave you, create an additional entry, right?
Yeah,
She said he's 4. Well, she actually could just use that one. So she was looking the other way. He's got 4, but he takes 16 water. He's got 4, takes 12 water. Who's stronger? Laredo, right? So Laredo has double 1s, So, whose was the strongest? Loretta's. So let's answer our next question. Put the juices in order from the juice containing most water to the juice containing least water. So what is our order? Okay. Who had the most water? Franca. Because she lost to everybody, right? Hers was the weakest. Who was next? Hi? Milton. Then our last one was Laredo.
But wait, isn't it the most?
That's the way it said here, whose juice would taste strongest, right? But this, guys, this is why we mark the text. What did the question ask? Put it from most water to least water. So even though this question said who's the strongest, which is how we looked at it, the follow-on question was reverse of that. And if you're not marking the text, you're not seeing that. Okay? So explain how you use the values. We found the strongest juice and reverse the order. I know. Okay, so the next section talks about what ratio. To find that ratio, all I'm going to do is take that initial entry, simplify it if I can. What can I divide 12 and 4 by? 4, thank you. Gives me a 4 to 1. Franca started at 10 to 2. What can I divide those by? 2 gives me a 5 to 1. And our last one, Milton started at 8 to 2. What can I divide that by? 2 again gets me 4 to 1. Oh, math there, that's 3 to 1. 12 divided by 4 is 3. That's what happens when I'm trying to hurry because we're out of time. Okay, guys, let's turn real quick to our homework, page 46. Okay, so, again, use ratio tables to determine who the fastest swimmer is. Show your wording. Guys, if you look really close, you may notice something about number 2 on your homework.
Subscribe.